Hi, everyone. So we're going to be talking about the periodic table. So it's going to be very helpful for you to have a couple things out. One is your note sheet that I handed out that we sort of been picking through. We're on page 4. If you see on my screen, that's the page that we're going to be looking at. And then also having a periodic table out. That's going to be super helpful too, because we're going to be writing on this and taking some notes on there. So I put a link to both of those in the assignment, so if you don't have either of those or don't have access to them, you can just pull that up. All right, so periodic table, the ultimate cheat sheet. So this periodic table, so what you guys are going to see is this thing is pretty amazing. Just the way that it's set up and the patterns that appear on the periodic table. That part is pretty ingenious. So this guy, Dmitry Mendeleev, you may or may not have heard of him before, but he was a Russian professor, and he was the first person to get credited with saying, hey, maybe there's like a different way that we can organize these things, or maybe there's a way to like put all these together. He basically took all the elements that were in existence at that time. He put them on note cards, and he just sort of moving them around and just trying to figure out, like, is there a sort of more organized way that we can put all these elements together so my students don't have to memorize them all? And he ended up with something that was very similar to the periodic table that we have right now. There was another guy who was doing the same thing, but Mendeleev gets the credit because he took it one step further. He predicted the properties of elements that had not been discovered yet. So, for example, germanium on the periodic table had not been discovered. They didn't know what that element was yet by the time he proposed this idea of this periodic table. He called it Eka silicon because he knew, I know an element should go here just because of the pattern that exists. I know what it's going to look like. I know the properties. So you can see over here, this is sort of what Mendeleev predicted this element would be like, just because he understood the patterns of the periodic table. And then later on, after he died, this was the actual properties of that element that hadn't been discovered yet. And lo and behold, they were really close to what he predicted. So he sort of had a vision to look and think about, like, well, how can I take this like one step further? It's almost like if you make a puzzle and there's one piece missing, you can sort of trace what that piece looks like. You know kind of what it looks like based on all the pieces around it. He sort of did the same thing because he understood there was a pattern to the periodic table. Okay, so much so that we have a law that's called the periodic law. And basically what this says is if you organize the elements on the periodic table, if you arrange them in a certain way, you will start to see a whole bunch of trends or a whole bunch of patterns will start to appear. And it's really nice because that prevents us from memorizing a lot of things if we sort of understand how the periodic table is laid out. Okay, so you may have heard of these terms before, but one of the groups on the periodic table, we call these the alkali metals. There's another group called the alkaline earth metals. There's another group called the halogens, and there's another group called the noble gases. So some of these groups or columns have very specific names. So what Mendeleev realized was similar groups on the periodic table or similar columns on the periodic table, they all share very similar properties. And that sort of gave rise to the way that he set this up. So they all share similar properties. So all the alkali metals, all the ones that are in the first group on the periodic table, these all share very similar properties. They can be replaced with one another sometimes because they have such similar properties. Turns out that alkali metals are very reactive in water. And as you go down the periodic table, they actually become more and more reactive. But they all react very similarly because they're in the same group. Okay, so on this periodic table right here, we have like the most general way to separate things on the periodic table. So what we have is, if you notice, we have this little stair-steppy line right here. And what we say normally is everything to the left of this, those are all going to be considered metals. Okay, so anything to the left of the periodic of the stair steps, we're going to call metals, with the exception of one, hydrogen. Right? Hydrogen is our red-headed stepchild of the periodic table. It does whatever it wants, whenever it wants. So hydrogen is way over here, but it actually is considered a non-metal. Everything else to the left is a metal. Everything to the right on the periodic table, those are our non-metals. And then we have all these purple ones that are sort of colored purple in the middle area here. They border the stairs. Those are called semi-metals, or sometimes we call them metalloids, because they have properties of both metals and non-metals. Okay, so I said groups and columns, but I need to make sure that that is clear for everyone. So the sort of geography of the periodic table, as you go down a column, we call those groups. Okay, so we just need to know that those are called groups as you go down. So this first group on the periodic table, this is called group 1A, or group 1. This second group right here, the second column, we call that group 2A. Now, on your periodic table that you guys have, it looks a little different. So the first thing I'm going to have you guys do is just make sure that you write 1A and you write 2A, because that's really what we want. Now this middle area right here, we actually don't use this numbering system for this middle area, but we do come over here, and instead of 13, we call this 3A. And instead of 14, we call it 4A. So you guys can cross that out on your periodic table and write in these numbers: 6A, 7A, and 8A. Okay, so we're not committing heresy by crossing stuff off on the periodic table. I know it feels weird. There's 3 different ways to number the periodic table. This is just one way to do it, and it's a lot easier than this sort of 1 through 18, which doesn't really give us as much information. Okay, so if we go back to our sheet here, so groups go down. So then the other thing that we can talk about is going across the periodic table. And if we go across, we call these periods. Okay, so there is 7 periods on the periodic table, and there are 18 groups going down the periodic table. Sometimes the periods are also called rows, but most of the time we call these things periods, and we call the columns groups. Okay, so we have columns going down, groups going across. 7 periods, 1 through 18 groups. All right, so that's sort of the easiest way to break down the periodic table. Now, there's a couple other ways to break it down. I'm not going to ask you to memorize this, other than you just need to know the names of these groups. Okay, so the other one that's in yellow here, these guys are called our main group elements. Main group. So everything in yellow is considered a main group. If it's not a main group element, then we consider it a transition element. In that middle area on the periodic table, those are what's called our transition metals. So that's our transition elements, okay? That's just another way to break down the periodic table. Main group, transition. Another way that you guys probably have heard of too is alkali metals is that first group, alkaline earth metals is the second group. This middle area, these guys are all called transition metals. Down below, technically these are called inner transition metals. Transition metals. Okay, again, that's that group that sort of has been taken out of the periodic table and dropped down. Those are called inner transition metals. And then as we go across, group 7A, those are called halogens. And this last group going down the periodic table, those are called our noble gases. Okay, so you guys just need to know the names of those different areas on the periodic table. Coincidentally, also, which is interesting, is this inner transition metal, it actually gets inserted right here on the periodic table. So the periodic table technically doesn't look like this. So here's another visual with colors where we have the different groups on the periodic table. Here's the inner transition metal taken out. This is actually what the periodic table looks like, with the inner transition metals actually inserted into the periodic table. It just doesn't fit on a piece of paper very well, and the inner transition metals have properties that allow us to sort of break it out and drop it down below the periodic table. But we just say like, hey, by the way, this actually gets inserted right there. Okay, so on our periodic table, what I'll have people do is you can just sort of draw a line like this and a line like that, sort of connecting that together. So technically this whole area gets inserted right here on our periodic table. We just drop it down for other purposes. The other thing you guys can write down are the periods. 1, 2, 3, 4, 5, 6, 7. And this is technically part of period 6. And this last row is actually also a part of period 7. So periods going across, groups going down. Okay. These questions, I think you guys can probably answer these pretty easily. It's just, list one thing that's a metal. All right, sodium's a metal. List a non-metal. Oxygen. List a metalloid. Silicon. So those are pretty basic questions I think you guys can answer just by looking at them. You're just sort of pulling stuff off the chart. The last thing I want to show you is on the next page. Okay, so this is on page 6, I believe. Yes, it is. The other thing we can do is we can look at sort of trends with ions. So what sort of ions are traditionally formed or most commonly formed by these elements? Well, it turns out that anything that's in group 1A, not a coincidence, they will all form +1 charges when they form ions. Group 2A, not a coincidence, these guys generally form a +2 when they form ions. Also, as we go across, group 3, these guys all form a +3. Now we skip group 4A because this is sometimes +4, sometimes -4, sometimes nothing. So we sort of don't use that very often. But when you get to group 5, you can say these guys, and some of these as well, will be -3 traditionally. Group 6, those guys are usually -2. The halogens are usually -1. And then the noble gases are 0. They are neutral. They don't have a charge. So these are the most common forms of the ions that are formed just by looking at the periodic table. So you start to see a pattern here. We don't have to memorize all of these because we sort of know just from looking at the periodic table what's the most common ion that will form. Okay. One other thing to point out is if it's in the transition metal area, it generally has more than one charge. Iron is a good one to look at because iron forms 2 different charges. It forms iron +2, but it could also form iron +3. Almost all of these transition metals can have variable charges. They can actually have more than one charge. So that's why we don't really put a pattern to those, although they will all be positive. We know that. All right. I think that's pretty much it. Like I said, you could probably go through and answer these questions, but just so you know where things are on the periodic table and you know how to read the periodic table. One other thing I would probably do on your periodic table is I would put a little +1 at the top here, +2, +3. And you can color this a different color if you want, -2 and -1. That sort of helps us remember when I go down this group, these guys are all +1, these guys are all +2, and so forth. I hope that was helpful.